4.5 billion years ago, Earth should have died. A rogue planet the size of Mars came screaming through the inner solar system. It struck Earth at 40,000 kilometers per hour. The impact didn't just crack the surface. It vaporized rock. It melted continents. It turned our entire planet into a ball of fire. Debris exploded into space. Millions of tons of molten rock formed a ring around what was left of Earth. From that ring, something formed. The Moon. For 50 years, scientists believed they understood what happened next. They were wrong. Here's what textbooks taught us. After the giant impact, the Moon was born as a molten sphere, a glowing ball of liquid rock orbiting a wounded Earth. Over millions of years, gravity did its work. Heavy metals like iron sank toward the center. Lighter materials floated upward. The surface cooled and hardened into a crust. Simple physics. Clean separation, predictable outcome. Scientists called this differentiation, the same process that shaped Earth, Mars, and Mercury. By the time the Moon finished cooling, it supposedly had 3 layers: a thin crust on the outside, a thick mantle in the middle, and a small, partially molten core at the center. Case closed. Mystery solved, move on. Except science doesn't work that way. Because 50 years later, researchers looked at the same data with new eyes, and they found something that shouldn't be there. In 2011, NASA scientists reanalyzed seismic data from the Apollo missions. Between 1969 and 1972, astronauts placed seismometers on the lunar surface. These instruments recorded every vibration, every moonquake, every meteor impact. The data traveled 384,000 kilometers back to Earth. Then it sat in archives. For decades, the original analysis was limited. Computers in the 1970s couldn't process complex wave patterns. Scientists made their best interpretations with available technology, but technology evolved. Modern supercomputers can simulate millions of wave interactions. They can model how seismic energy travels through different materials with incredible precision. When researchers fed the old Apollo data into new simulations, something unexpected emerged. The seismic waves weren't behaving the way the old model predicted. Some waves traveled too fast. Others reflected at angles that didn't match a simple molten core. The patterns suggested something denser at the very center, something solid. After extensive modeling, the team published their findings. The Moon doesn't have a simple core. It has a layered core, a solid inner core made of iron, roughly 240 kilometers in diameter, surrounded by a fluid outer core about 90 kilometers thick, exactly like Earth. This might sound like a minor technical update. It's not. The structure of a planetary core determines everything. How heat escapes, how long a world stays geologically active, whether it can generate a magnetic field. Earth's magnetic field exists because of our layered core. Liquid iron in the outer core flows around the solid inner core. That motion generates electrical currents. Those currents create the magnetic field that shields our atmosphere from solar radiation. Without that shield, solar winds would have stripped away our air billions of years ago. No magnetic field, no atmosphere, no life. Here's what's fascinating. The Moon once had a magnetic field too. Apollo astronauts brought back rock samples. When scientists analyzed them, they found evidence of ancient magnetism locked inside. Billions of years ago, the Moon generated its own protective field. Today, that field is gone. Why? A layered core structure might finally explain this mystery. When the Moon was young, its outer core was hot and fluid. Convection currents flowed vigorously. A magnetic dynamo operated, but the Moon is small. It cooled faster than Earth. As heat escaped, the outer core solidified. Convection slowed. The dynamo weakened. Eventually, it stopped completely. The magnetic field faded. The Moon became magnetically dead. A solid inner core would accelerate this process. As iron crystallizes at the center, it releases heat. That heat initially drives convection more intensely, but once crystallization completes, the energy source disappears. The timeline of the Moon's magnetic death might now be recalculated. And that timeline connects directly to Earth. The Moon isn't just a pretty object in our sky. It's the reason we exist. Earth's axis tilts at 23.5 degrees. That tilt creates our seasons. Summer, winter, the annual cycles that ecosystems depend on. Without the moon, Earth's tilt would wobble chaotically over millions of years. Sometimes 10 degrees, sometimes 60 degrees. Unpredictable, extreme. Ice ages would become catastrophic. Tropical regions would freeze. Polar regions would bake. Complex life needs stability. Evolution needs time. Ecosystems need predictable patterns. The moon provides that stability. Its gravitational pull acts like an anchor. It keeps Earth's tilt within a narrow range. It has done this for billions of years, but here's the deeper connection. The moon's internal structure tells us about the original collision. If the moon formed with enough iron to create a solid inner core, the impact might have mixed materials differently than we assumed. Perhaps more of Earth's core was ejected. Perhaps the collision happened at a different angle. Perhaps the impacting planet was larger or denser. Each adjustment to the moon's composition ripples backward through time. It changes the story of how Earth survived. Current models estimate Earth lost significant mass during the impact. The collision stripped away parts of our original mantle. It reset our planet's evolution. If the moon's core is denser than predicted, the mass exchange might need recalculation. Small changes compound over 4.5 billion years, the oxygen we breathe. The magnetic field that protects us, the stable climate that allowed evolution to proceed, all of it traces back to that collision, and the moon's core is a fossil record of that moment. This discovery extends far beyond our solar system. Astronomers have confirmed over 5,500 exoplanets. Many are rocky worlds orbiting distant stars. Some sit in habitable zones where liquid water could exist, but we can't see inside them. We measure their mass by how much their gravity tugs their parent star. We measure their radius when they pass in front of that star. From mass and radius, we calculate density. Density tells us whether a planet is rocky like Earth or gaseous like Neptune. But internal structure remains invisible. This is where the moon becomes invaluable. Every model of exoplanet interiors relies on physics we've tested locally. Earth, Mars, Mercury, the moon. If we misunderstand how small rocky bodies develop layered cores, we misunderstand how exoplanets evolve. Core structure affects magnetic field generation. Magnetic fields affect atmospheric retention. Atmospheres affect surface conditions. Surface conditions affect habitability. The chain is unbreakable. When scientists search for habitable exoplanets, they're not just looking for the right temperature. They're looking for worlds that can maintain stability over billions of years. Worlds with magnetic shields, worlds with stable atmospheres, worlds where chemistry had time to become biology. The moon is our closest laboratory for testing these models. Every refinement to lunar science improves our predictions about worlds we'll never visit. A 240-kilometer iron ball inside the moon helps us search for life among the stars. The Apollo program ended in 1972. The last astronaut left the lunar surface over 50 years ago. The seismometers stopped transmitting in 1977. But the data never stopped teaching us. Science is not a collection of facts. It's a process of refinement. Each generation inherits data from the last and asks sharper questions. The astronauts who placed those instruments couldn't have imagined the computers we use today. They recorded vibrations without knowing what patterns would emerge decades later. They trusted the future, and the future delivered a solid inner core, a layered structure, a new chapter in the moon's biography, not a revolution, not a rejection of everything we knew. A refinement. The moon still rises over the horizon tonight. It still pulls at our oceans. It still stabilizes our planet's spin, but now we know something more. Deep beneath the gray dust in ancient craters, at the very center of that silent world, sits a small iron heart. Dense, solid, hidden for 4.5 billion years, finally discovered. 4.5 billion years ago, Earth nearly died in fire and chaos. Instead, from that destruction, two worlds emerged. One became home to life. the other became its guardian. And inside that guardian, we're still finding secrets. The moon looks simple, it never was.